Addition and subtraction of vectors. The process of adding two or more than two vectors is called addition or composition of vectors. When two or more than two vectors are added, we get a single vector called the resultant vector. The resultant of two or more than two vectors is a single vector which produces the same effect as the individual vectors together produce. Three laws have been evolved for the addition of vectors. They are triangle law of vectors, parallelogram law of vectors, polygon law of vectors. Click on the links provided. Triangle law of vectors. Let a particle be at the points A, B and C at three successive times t, t', t", respectively. Vector AB is the displacement vector from time t to t'. Vector BC is the displacement vector from time t' to time t'. The total displacement vector AC is the sum or the resultant of individual displacement vectors AB and BC. Therefore, vector AC is equal to vector AB plus vector BC. This is known as the triangle law of vectors. That is, if two vectors are represented both in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. This law is used for the addition of two vectors. The magnitude and direction of the resultant vector r is given by the equations r is equal to square root of p squared plus q squared plus 2 pq cos theta, beta equal to tan inverse q sin theta divided by p plus q cos theta. Mouse over on the formula for the derivation. Parallelogram law of vectors. According to the parallelogram law of vectors, if two vectors p and q are represented by two adjacent sides of a parallelogram, both pointing outwards, then the diagonal drawn through the intersection of two vectors represents the vector sum of p and q. Let two vectors p and q be completely represented by the two sides OA and OB respectively of a parallelogram, and theta be the angle between the two given vectors, vector p and vector q. Then, according to parallelogram law of vectors, the diagonal OC of the parallelogram will give the resultant vector r such that vector r is equal to vector p plus vector q. The magnitude and direction of the resultant vector r is given by the equations r is equal to square root of p squared plus q squared plus 2 pq cos theta, beta equal to tan inverse q sin theta divided by p plus q cos theta. Mouse over on the formula for the derivation. Polygon law of vectors. Polygon law of vectors is used for the addition of more than two vectors. Let us consider four vectors, vector p, vector q, vector s and vector t as shown in this figure. Displace vector q parallel to itself till the tail of vector q touches the tip of vector p. Similarly, displace vector s parallel to itself till the tail of vector s touches the tip of vector q. Again, displace vector t parallel to itself so that its tail touches the tip of vector s. Now, a vector r running straight from the tail of vector p to the tip of vector t will be the resultant of vector p, vector q, vector s and vector t. This is the polygon law of vectors. It states that if a number of vectors can be represented both in magnitude and direction by the sides of an open convex polygon taken in the same order, then the resultant is represented completely in magnitude and direction by the closing side of the polygon taken in the opposite order. Suppose four vectors, vector p, vector q, vector s, and vector t, are represented completely by the four sides AB, BC, CD, and DE respectively of a polygon, all taken in the same order as shown. Then, according to the polygon law of vectors, the closing side AE of polygon taken in the opposite order will completely represent the resultant vector R such that vector R is equal to vector P plus vector Q plus vector S plus vector T.